In this video, we're going to talk about the order of operations. I know that a lot of students in high school are taught that the order of operations are PEMDAS, which is please excuse my dear Aunt Sally. And I hate to burst your bubble, but that simply is not necessarily true. It's kind of almost misguiding or a little bit false or misleading, you might say. The first order or the first operation in the order of operations is not strictly parentheses. Parentheses is one such example. It's actually grouping symbols. And grouping symbols, there's lots of different types of grouping symbols that we can include here, parentheses being just one example. So here are some examples. Parentheses, we also have brackets, we have fraction bars, we have absolute value bars. Be careful with absolute value though, you can never distribute with the absolute value bars. And then square root, which again, you can't distribute anything, so if there's a number on the outside of the square root, or any root for that matter, you cannot multiply what's inside by that number. But these are just a couple examples. There are more. These are probably the most common ones that you'll run into. Okay, so the first order or operation in the order of operations is grouping symbols. The second would still be exponents. The third is going to be multiplication and also division, and that's one of the things that I feel the PEMDAS rule kind of doesn't do well. It just says simply multiplication, then division. It kind of insinuates that there's an order to it, meaning one is more important than the other, and that's not really true. So this is multiplication. I'm going to abbreviate this, multiplication and also division. So you might ask, if they're both equally important, how do you know which one to do if you have a series of multiplication and division? Well, in this case, you move left to right. And then finally, my last operation is, again, not addition then subtraction. It is actually addition and subtraction. All right, again, and I abbreviated that, you have to go left to right. All right, so let's practice using these four order of operations in the correct order for the next two problems. All right, with this first problem, what we see is a couple different grouping symbols. We see brackets and then we see parentheses. And when we see more than one grouping symbol, we must go to the innermost grouping symbol, which would be the parentheses here, and evaluate inside the innermost parenthesis or innermost grouping symbol first. So everything else gets dropped down, 4 plus 2, and now instead of 10 plus 6, we have 16 by actually adding those two. Now, again, we want to go to the next grouping symbol that we see, which is the brackets, and do our order of operations inside the brackets. Notice we have addition here, and we have multiplication here, and according to our order of operations, multiplication comes before addition. So we now have 2 plus bracket 4 plus 32. And now we do 4 plus 32, which is 2 plus 36, which then results in 38. Now, there is actually an alternative way of doing this problem, and that's the beauty of math. There's typically more than one way to do problems in math, and so this is an example of that situation. So I'm going to redo this problem, and instead of actually adding this 10 plus the 6, finding the sum of 10 and 6, I'm going to use the distributive property. So I'm going to take the 2 plus bracket 4 plus, now what I'm going to do for the second method is to distribute this 2. So now I have 20 plus 12. All right, so again, this is an alternative method, should result in the same answer. And again, that's the point of the order of operations, is that we can do these things and all result in the same exact answer by doing the correct order of operations. If there was an order of operations, we'd all get different answers. 4 plus 20 is 24. 24 plus 12 is 36. So we have 2 plus 36. I'll continue to keep this in brackets, which results in 38. It doesn't matter which method you do. The second problem is a little different. We do still have a grouping symbol. Notice, though, the grouping symbol in this case is the fraction bar. Now, the fraction bar does represent division, but in this case it's grouping because we have operations in the numerator and denominator that we must do before we could divide or simplify the fraction. So the numerator is 7. The denominator is 2 plus, and we must multiply first before we add, so that'll be 28. And so then we add 28 plus 2 and we get 7 over 30. Now with all fractions, I don't want these to be decimals unless specifically stated. They should remain as fractions. Fractions are wonderful. They're exact. They're perfect. But we should always try to reduce the fraction. This fraction, however, cannot be reduced. So that is our final answer.
And that's all, folks.